Scanners are every bit as important as printers in the wide format market. They're an essential part of every wide format copier, and they're widely used to create digital files from hard copy originals. Scanning wide format documents to create digital files means we need documents, of course, a wide format scanner, and somewhere to store those digital files we create. For example, when we scan, we create raster files like TIFF or JPEG and so on, and sometimes even PDF files. We'll cover Scan to File as an application in more detail in a later part of this course, and we'll also talk about digital storage, managing a digital document repository. For now, let's just take a look at the technology of wide format scanning. Wide format scanners use either of two primary imaging technologies: CIS, which stands for Contact Image Sensor, and CCD, which stands for Charge Coupled Device. They both work by shining bright light onto the target document when scanning, and then capture that light reflecting off the document with sensors. Let's take a look at each first, and then talk about their relative advantages and disadvantages. First, let's look at the CIS type of scanner. Besides the mechanical parts that move the document through the scanner, a CIS scanner has four main components. First, a light source, usually an assembly of red, green, blue, and sometimes white LEDs. The light from the LED array gets evenly distributed over the width of the document. Second, a collection of fiber optic rods and lenses that focus on the third element, the CIS sensor assembly, and lastly, an analog to digital converter. The light source, fiber optic lens array, and CIS sensor all get assembled into a single module, and they're set close to the document surface, usually at a ½ inch or less, hence the name Contact Image Sensor. In operation, light from the source reflects off the document, through the fiber optic lens, and onto the surface of the CIS array. There is one fiber optic rod and lens, and one sensor element for each pixel. That means in a 600 dpi scanner, there would be 600 lenses and 600 sensors per horizontal inch across the entire width of the scan head. Each element in the CIS sensor generates a voltage in proportion to the amount of light it detects. The A to D converter changes this voltage to a digital value for processing. The system scans one line at a time and then advances the document by one line so it can scan the next, and so on, making it a raster device. Compared to the fluorescent lamps used in some scanners, LEDs turn on instantly, use less power, and last forever, all advantages. They're limited, however, by their color gamut when compared to CCD scanners, which means they're not as well suited for scanning photographic documents or where high-fidelity color is required. In addition to the document transport system, a CCD scanner uses five main components: a light source, which is usually a fluorescent-type lamp, although some manufacturers are now using white LEDs, mirrors, a focusing lens, CCD sensors, and an analog to digital converter. The fluorescent light shines on the document, reflects through a series of mirrors, through a focusing lens, and onto the surface of the CCD sensor. The CCD assembly has a series of RGB filters on it to separate the colors. The CCD creates a voltage in proportion to the amount of light received. The A to D converter changes this voltage to digital for processing. Some designs use up to 4 separate CCDs, each with its own color filter, to segregate the red, green, blue color information. When used, a fourth CCD captures monochrome data. Compared to CIS scanners, CCD scanners have a higher color fidelity, higher resolution, and better overall image quality. But they require frequent calibration to offset the drift characteristics of their fluorescent lamps and their optical mirrors and lenses. Everyone always asks, which is better? Well, all the vendors will tell you that their technology is the best. But it really depends on the application and how much you want to spend. The guidelines are: CIS is suitable for most applications, especially in the wide-format CAD, AEC, and GIS markets. It will give satisfactory results at a fair price. CCD is best suited to fine and graphic arts applications where accurate color is most important. But since these images will most likely also be printed, you'll also need high-end RIPs and graphic arts printers to make it all work.